What do you think of when I say radioactivity? Sounds scary, right? Makes us all imagine nuclear explosion, genetic mutation into something green and glowing. But in fact, it's a naturally occurring phenomenon. It's in the air we breathe, food we eat, me, you, everything is radioactive. Most of the natural radiation traces its origin to uranium, the boogeyman of the periodic table. This guy has not the best reputation, but without it, we will not have nuclear power, a dream of a clean and limitless energy. Currently, 11% of the world's electricity is produced by 450 nuclear reactors. They allow reliable production of carbon-free electricity 24/7, which doesn't depend on weather or geographical location. But this is only half the story. There is a nasty part to it, which is uranium mining, milling, and storage of the nuclear waste. These are the ways for uranium to get into the environment in dangerously high concentrations. If it happens, uranium reacts with oxygen in atmosphere and gets oxidized to uranium-6, highly soluble form of uranium. If it happens, then uranium can travel with rivers and groundwaters, spreading pollution for miles from its source and get into the water supply. This can be very dangerous. Uranium can cause lung and kidney failure, amongst many other health complications. Fortunately, though, a few years ago, it has been found that certain type of bacteria can transform uranium from soluble to insoluble by the reduction process, by giving 2 electrons to uranium-6 and making it uranium-4. Uranium-4 is no longer soluble and therefore cannot contaminate our drinking water. At EPFL, we are working on understanding precisely how the mechanism of this reduction works, so we can make bugs to do this job faster and better. Our idea was that uranium-5 species in between uranium-6 and uranium-4 may play a key role in this mechanism. But until now, it was not possible to test this hypothesis, as it was thought that this species is highly unstable in water. We have decided to stabilize this molecule by attaching different other organic molecules to it, something what we call ligands, and this way to protect it from destructive influence of water. After quite some numerous laboratory trials, we were able to prepare the first uranium-5 complex stable in water, and now we're in position where we can give this compound to bacteria and hopefully soon enough figure out the mechanism of this bioreduction. So, even if glowing in darkness might be practical at the times, I think we should avoid it at all costs. And hopefully our research will help to develop better remediation technology for uranium cleanup. Thank you.